let's take a look at this reviewed for our problem to factor this polynomial x to the fifth plus x to the fourth minus 5x cubed minus 5x squared minus 14x minus 14. This one can be done without actually resorting to the rational root test or even looking at the graph. This one can be done by grouping. So let's take a look at the first two terms. I can factor out x to the fourth out of the first two terms. Then on the next two terms, I can factor out negative 5x squared, leaving me another x plus 1. And then on the last two terms, I can factor out 14, leaving me another x plus 1. If I were to multiply this out, I would get the top line. I see that x plus 1 is common to all three, so I can factor that out. X plus 1, x to the fourth minus 5x squared minus 14. And so I factored. And I'll leave it for you to check that if you use synthetic division on this with -1, you'll get the exact same quotient with synthetic division. But in this case, I didn't need synthetic division to be able to factor. All right, this thing is quadratic in form. And so that also factors. I can factor as x squared and then x squared. And the terms I'll need are -7 and +2. So x squared times x squared is x to the fourth. -7 plus 2 makes -5x squared, and -7 times +2 is -14. Okay, now to factor this over the real numbers, this is actually the difference of two squares, and I can write that as x minus square root of 7, x plus square root of 7, and then x squared plus 2. This factors over the complex numbers, but for the purposes of this problem, we're just going to factor over the real numbers. And so this is our factorization, and so I can read off the roots are going to be -1 plus square root of 7, negative square root of 7, and the roots of this will be plus or minus I times square root of 2 by looking at it, or else if necessary using the quadratic formula. But in this case, when you look at it, x squared equals -2 implies that x is either plus or minus I square root of 2. And so those are our 5 roots. We can confirm this by looking at the graph of the polynomial. So if I put the graph of the polynomial on screen, we see one root here at -1. There's a root over here between 2 and 3 that corresponds to positive square root of 7. And there's another root over here between -3 and -2 that corresponds to negative square root of 7. But the two complex roots do not correspond to actual x-intercepts.